Somewhere in the universe, there are stars that do not warm worlds. They erase them. We tend to think of stars as life givers, steady suns that nurture planets, fuel ecosystems, and make existence possible. But not all stars play that role. Some are so violent, so unstable, and so overwhelmingly energetic that nothing can survive anywhere near them. If Earth were placed close to one of these stars, the oceans would boil away in minutes. The atmosphere would be ripped apart molecule by molecule. The crust would crack. And within a shockingly short time, the planet itself would be reduced to glowing debris. These are not theoretical stars. They exist. And they are among the most dangerous objects in the universe. They are called hypergiants. Hypergiant stars are the most massive and luminous stars ever discovered. They burn millions of times brighter than our sun and pour out unimaginable amounts of radiation every second. Unlike stable stars, hypergiants live fast and violently. They shed mass, erupt unpredictably, and edge constantly toward catastrophic collapse. To understand how deadly they are, we need to understand scale. Our sun produces an enormous amount of energy, about 400 trillion watts. That number is already beyond human comprehension. Yet, a hypergiant can emit millions of times more energy than that, concentrated into fierce stellar winds and radiation fields that extend far into space. These stars do not just shine, they attack their surroundings. Their radiation is so intense that it strips electrons from atoms at extreme distances. Their stellar winds travel at millions of kilometers per hour, carrying enough force to physically peel atmospheres away from nearby planets. Even solid rock cannot remain stable under this assault. A planet orbiting too close to a hypergiant would not simply overheat, it would be dismantled. First, the upper atmosphere would ionize and escape into space. Then the oceans would evaporate into thick, superheated vapor. Then the surface would melt into magma oceans. Finally, the planet's gravity would lose its grip on its own material, and the planet would begin to come apart. This process is called atmospheric stripping, but that name barely captures the horror of it. It is slow annihilation, stretched over months or years. A planet dying layer by layer, unable to defend itself. Astronomers have already observed this happening around smaller, less violent stars. Hot Jupiters, massive gas planets orbiting close to their suns, are actively losing their atmospheres, forming glowing tails of gas like cosmic comets. Now imagine that process amplified 1,000 times. That is what happens near a hypergiant. Some hypergiants are so unstable that they experience massive eruptions, sudden blasts that eject material equivalent to multiple suns into space. If a planet were nearby during one of these eruptions, it would be sterilized instantly. And the danger doesn't end there. Hypergiants are ticking time bombs. They are destined to die in colossal supernova explosions, blasts so powerful they briefly outshine entire galaxies. When that happens, any planet within hundreds of light years could be irradiated by lethal gamma rays and cosmic shockwaves. A hypergiant doesn't just kill its own planets, it poisons vast regions of space. Which raises a disturbing question. If stars like this exist, and we know they do, how many planets across the universe have already been erased without a trace? And more unsettling still, what if some planetary systems never had a chance to begin with at all? When astronomers search for exoplanets, they often focus on calm, stable stars like our Sun. Stars with predictable lifespans. Stars that give planets time to form, cool, and evolve. Hypergiants are the opposite of that. They burn through their nuclear fuel at an obscene pace. While our Sun will live for around 10 billion years, a hypergiant may last only a few million, sometimes less. That may sound like a long time, but in cosmic terms, it's barely enough time for planets to finish forming. And even if planets do form, survival is unlikely. The environment around a hypergiant is chaos. The star's radiation pressure can be so strong that it prevents dust and gas from clumping together in the first place. Without that clumping, planets never fully assemble. They remain as scattered debris, failed worlds that never become whole. But in systems where planets do manage to form, their fate is grim. Astronomers have detected massive streams of gas flowing away from planets orbiting hot stars, evidence that these worlds are literally evaporating. Some planets lose the equivalent of Earth's entire atmosphere every few thousand years. Near a hypergiant, that rate would be catastrophic. Rock itself begins to vaporize at extreme temperatures. Silicate minerals, the building blocks of rocky planets, turn into gas. The planet stops being solid and becomes a glowing cloud of atomic debris. In essence, the star converts planets back into raw material. And this destruction doesn't happen quietly. As the planet loses mass, its orbit destabilizes. It may spiral inward, accelerating its own destruction, or be flung outward as a shattered remnant. A planetary corpse drifting through space. This could explain a mystery astronomers have long puzzled over: rogue planets. These are planets that wander the galaxy alone, untethered to any star. Some estimates suggest there may be more rogue planets than stars in the Milky Way. Many were likely ejected during chaotic early system formation, but others may be survivors or remains of stars that destroyed their own systems. A hypergiant doesn't just kill planets. It leaves behind ghosts. Even after the star dies, the damage continues. When a hypergiant explodes as a supernova, it floods space with radiation and heavy elements. Any nearby planets that somehow survived the earlier phases are bathed in lethal energy. Their surfaces are scorched. Their atmospheres collapse. Their chemistry is permanently altered. Life, if it ever existed, would be erased down to the molecular level. And there's another, even darker possibility. Some hypergiants may collapse directly into black holes without a visible explosion. In these cases, planets might continue orbiting, unaware that their star has vanished. Imagine standing on a planet where the sun suddenly dims, then disappears entirely. Temperatures plummet. The sky goes black. Gravity shifts. Orbits destabilize. And slowly the planet freezes solid, locked in eternal darkness. Whether through fire or cold, hypergiants ensure one outcome: nothing lasts. And this leads to a chilling realization. If intelligent life ever evolved near one of these stars, it would be racing against extinction from the very moment it began. Civilizations would rise knowing their sun was unstable. Their skies would be filled with violent stellar eruptions. Their calendars would be countdowns. They would live under a star that could erase them at any moment. Which brings us to the final question. Are hypergiants simply cosmic accidents? Or are they the universe's way of reminding us how fragile planets and life truly are? In the grand structure of the universe, hypergiant stars occupy a strange role. They are creators and destroyers at the same time. The heavy elements that make planets, iron, oxygen, carbon, are forged inside massive stars. Without stars like hypergiants, the universe would lack the materials needed for worlds like Earth to exist. But the same stars that create those elements also ensure that many worlds never survive long enough to use them. Hypergiants are cosmic executioners. They shape galaxies through violence. Their intense radiation sculpts nebulae. Their winds seed space with matter. Their deaths trigger new waves of star formation, while simultaneously sterilizing enormous regions of space. From a distance, they are beautiful. From nearby, they are fatal. Our sun is a gentle anomaly, a stable, middle-aged star that allows life to unfold slowly. But most stars in the universe are not so kind. Many are far more violent, and hypergiants represent the extreme end of that spectrum. They remind us that planets are not guaranteed safe havens. They are temporary arrangements of matter, existing at the mercy of forces far beyond their control. Somewhere right now, a planet is being stripped bare. Somewhere, an ocean is boiling away into space. Somewhere, a world is dying without witnesses. And one day, billions of years from now, even our own sun will grow unstable. It will swell. It will consume the inner planets, and Earth too will be erased. Not by a hypergiant, but by the same cosmic indifference. The universe does not protect planets. It does not preserve life. It does not care who survives. Stars burn, planets die, and space moves on. This is not science fiction. This is astrophysics. And the most terrifying stars in the universe are not black holes. They are suns that burn too brightly for anything to survive. Subscribe for more dark science files.